Okay, let's start today's discussion. Have you gone through the week 3 assignment?
Yes,
Okay, it is okay. Could you able to solve it or some difficulties
yes,
are there?
some doubts are there, but mostly good thought.
Okay, okay. Okay, let's start today's discussion. Is my screen visible?
Yes, sir.
Okay. Okay, so let's start today's discussion. So our first question is the absolute configuration of the following molecule is. So at first tell me which kind of chirality is present here. Means it is chiral axis or chiral plane. Which kind
So
of
chiral axis.
yes, chiral axis is present here due to the presence of allene. The two cumulative double bonds are perpendicular to each other, so there is chiral axis is present there, right? Okay, so tell me what is the correct answer? What is the configuration? So how can we determine the uh, configuration of the chiral axis? Let's discuss with this example. Okay, so there as we see that it has the different kind of planes. So we can determine the chiral, configuration of this chiral axis from two sides, either from this side or either from this side, right? So when we are viewing from this side, right? So we have to uh, emphasis on this axis first. So this axis says that this one is above the plane and this one is below the plane, right? So if we are viewing from the left side, that is from this side, then we have to darken this line, that is this one is above the plane and this one is below the plane. So according to this one, which one is of the highest priority, this one or this one? Benzene ring or
The
sorry,
wedge bond, that the one which is above the plane.
which is above the plane, because it is connected to the carbon again and this is only one double bond is there, right? So if we are viewing from left side, then the above the plane which be in which side, right or left?
So right.
Right, exactly. So we will put this as the priority 1, right? And this one as the priority 2. Okay? And then the backward carbon we will put as the vertical line. And which one is of the highest priority in this carbon? This one or this one?
That, that one which is has double bond O.
Yes, double bond O, that is of the higher priority, right? So we will put it as the 3. And then usually we will put the 1, 2, 3. And what is this? R or S?
S.
S. So we it depends on the from which side we are viewing this molecule. If we are viewing from this side, then this bond will be darkened. We can also determine from the this side, right? Then this bond should be emphasized. Then this will get the first priority. And then the phenyl group will be on which side, right or left?
So what is the question?
Means if we viewing from the this side, then what will be the orientation of this side? Means phenyl ring will be the on the right or left? Viewing from this side we are viewing.
Sir, right?
No, above the plane, that is this side, no? That is it
That
will
is
be
left side.
left side, yes. So, one, two, three.
Sir, can
Again,
you repeat once again how which functional group is coming on the left side again?
yes. So, when we are viewing from this side, okay, from the right side, right? So, we are darkening the this one, this one, we are darkening. Okay, so it is no problem. It is one, it is two, because it is of the highest priority as carbonyl is there, and it is of the lower priority. It is clear.
Yes, sir. Yes, sir. The back one.
Okay, the back one. Then as we viewing from the this one, then this is one is the above the plane and this will in the below the plane. So if we viewing from the this side, then definitely the benzene ring will be come in this side.
Ah, yes, sir. It's clear, sir.
Left side.
Okay, so we can determine from the both side, either from the right side or from the left side. Any side we choose, we will get the same result. Okay.
Yes, sir.
Okay, then going to the next question. Okay, which one is polymer? Is we give the stable atropisomer at room temperature. At first, you tell me first what is atropisomerism. Any knowledge or any idea about the atropisomerism?
Can
Sorry, your voice is not clear.
you
Okay, let's have some idea.
That the second one where the
repeat
OH and BR is lying near to it, that won't be in the same plane. Something related to that it
any
was.
Okay, let me explain.
cyclohexane
Okay, let's have this example. Okay. Okay, this is that there is a two phenyl ring attached to the one bond. What kind of system it is called? It is called biphenyl system, right? So this bond is called pivotal bond. Okay. So when there is no substituent on the benzene ring, this bond can freely rotate, right? Freely rotate, and it can move around the single bond is freely rotate as we know. But when some bulky group is there, then the rotation around the single bond is restricted. Okay, so the two phenyl ring, due to some repulsion of these groups, these two rings cannot stay in the same plane. Okay, so one, sorry, so if one is in the this plane, the another remains. Can you get it? That this phenyl ring is if in the plane of the paper, then this phenyl ring, two arm, due to the substitution of the ortho position, one, this is perpendicular to this phenyl ring, right? Then there is presence of the chiral axis. Then this kind of isomer is called as the atropisomerism. Is this clear?
Yes,
Yes,
sir.
sir.
Okay. So, due to the presence of this bulky group in the ortho position of the phenyl ring, this kind of isomerism occurs. There is also one conformer of this molecule. Like if A is in the above the plane, in the next conformer, this A may be below the plane. And these two conformer are has the same configuration. These two molecules, this one and this one,
No, sir.
they are enantiomer of the each other. The absolute configuration will be reverse of each other, right?
Yes, sir.
Yes. So this kind of isomerism, this kind of this kind of isomerism is called the atropisomerism. Okay.
Yes, sir.
So the criteria of the atropisomerism is that ortho position should be highly substituted or bulky group should be there, so that assume there is a interaction and the free rotation of around the single bond is restricted, right? So this one is the criteria of the atropisomerism. So tell me which compound will show the atropisomerism at room temperature. Let's start with 4. Will it show atropisomerism?
No,
Sorry?
no, no, no.
No, exactly. Then as it is fixed one, right? There is no possible rotation. It is already fixed in its position, right? In 4.
Yes.
And in case of 3,
No, because if there would be a substituent near F, then it would exhibit.
yes, yes. This is only one substituent is there, so it can rotate around the single bond. So only left is 1 and 2, so they will show the atropisomerism.
Sir,
So
in the previous question, can you explain how one is showing atropisomerism because it's not a biphenyl system?
yes, it is not a
Because there is group and isopropyl group is near to each
yes,
other.
yes, near to each other due to steric repulsion. They will be in the another plane. Okay,
Okay, sir. Yeah,
okay.
yeah.
If it is simple bicycle like naphthalene, then it is completely planar. That is a sigma plane will pass through the molecular plane. But due to presence of the bulky group in ortho position, it is not planar one and not it is optically active. Okay.
Okay, sir.
Okay. Then what is the correct answer here? In B, the absolute configuration of this molecule. Tell me. From which side we will determine? From right or left? You tell me.
Right.
Right means this one.
Yes.
Okay. Then if we determine from the this one, then we have to which one is the highest priority? This one or this one?
The one
Sir,
with
the one
fuel.
with fuel.
Carbonyl carbon both
Highest priority.
highest priority. Okay.
That is right side.
Yes. And in the back carbon, this carbon or this one?
Above one. Highest
Above.
priority.
Yes. CO2 ET will be there. Right?
Yes.
Then 1, 2, 3, and the configuration is
R.
R. So we will get the same result. If we do this from the left side, we will get the same priority. Okay.
Sir, shouldn't the COH group be taken in the vertical line in this when we are seeing from the right side?
No, when we are seeing from the right side, as you see that this is perpendicular to the plane of the paper. This one is the above and this one is the below. So when we are viewing from this side, we will accordingly we will put, that is, this one is 1, this one is 2. Okay, like this way we are putting the priority one. So when if we are viewing from the right, then it is the perpendicular to the plane of the paper, then we will put in the horizontal line. And if it is in the plane of the paper, then we will put in the vertical line.
Okay, okay, sir. So when we're doing from the left, will it come on the vertical line?
Yes, yes. Then we will dip this vertical line and we will do accordingly the back carbon accordingly.
Okay, okay, sir.
Okay. Now tell me, what is this syn or anti orientation of this molecule? You know the syn. Which conformation is called the syn?
Sir, syn is when both the functional groups are either alpha or beta, and anti is when they're opposite.
They are opposite. They are in opposite side, right?
Yes, sir.
Okay. So tell me which one is the correct answer here. Let's first convert it to the Fisher, right? Then it will be easy to understand for us. Okay, it is right. So we have to check around the 2, 3 and 3, 4. That is around this bond and around this bond. So in if we look around the 2, 3 bond, then what is the configuration of this 2, 3 bond? Syn or anti?
Sir, it's syn.
It's syn, as the like group is in the same direction, right? Here 2 OH and here 2 hydrogen are there. Okay. Is it clear?
Yes, sir.
And if we look around the 3, 4 bond, then what is the orientation? What is the orientation around 3, 4 bond?
3, 4 bond also it is syn.
Yes, it is syn because the like group hydrogen are in the same orientation.
Right.
And here also in 3 carbon, OH is of the higher priority, highest priority, and in the 4, fluorine is of the higher priority. They are also in the same direction, right?
That's right. Yes.
So it is also syn, and this bond is also syn. Okay. So this one is the right answer. Both are syn, right?
Yes.
Okay. Now tell me which of the following compounds are not resolvable at 25 degrees centigrade. Which concept we will utilize here to solve this problem? We discussed earlier in today's class.
Optical activity.
Optical activity, definitely. When it is question of resolving isomer, then it is obviously optical activity. but there is a specific term I discussed in the first slide. It is special kind of isomerism,
Atropine.
atropisomerism. Okay, so in as we state earlier that in atropisomerism, that at room temperature the flipping of the two bond around these two phenyl ring when connected to the single bond, thus energy of this bond is very low, that is at room temperature it can rotate around, right? So it can be possible, it can stay in any form, whether it is R or S, it can stay in any form. So tell me which one is not resolvable at room temperature. Let's start with one. Will it show atropisomerism?
No.
No.
No, as the two phenyl ring, this one and this one is completely in Cajun framework, right? In strict framework, so it cannot rotate around this single bond. Okay,
Yes. Yes.
okay. And in case of four, will it show atropisomerism?
No. This is also same thing. Caging.
This is also same thing. In case of three, it is also the same two bonds are there, tertiary butyl bonds are there, so it cannot show optical isomerism. So only left is option two. Okay, due to the higher
So Me and B are two bulky group side
yes,
by side.
yes, there are two bulky group. NO2 is bulky group, and also bromine and CO2 is there. So it will be formed. It will stay in the two form, and it is not resolvable at the room temperature. Okay. Now tell me, what is the case with this molecule? The absolute configuration is what? Tell me what? How will it proceed? We will proceed for the R or S or E or Z. At first, tell me that.
E and Z.
E and Z. Why? Why not R or S?
Not stereo center.
Not chiral at all. Okay. This is in one plane. This moiety, and this one is the above the plane. This one below the plane. Right. This one is the sp3 center. So tetrahedral in nature. Right. So this one is the tetrahedral. This group is above the plane. This one is the below the plane. Okay. So if we imagine a sigma plane regarding this page, then this will this will divide the molecule in equal half, right? So it is not optically active at all. So we cannot designate as it R or S, right? Is it clear?
Yes, sir.
Okay. So now tell me regarding E or S, sorry, E or Z, which one is the right option?
Sir, it's on opposite side, so it'll be E.
Exactly. If it is in the double bond and this carbon the higher priority is, and for this carbon this is the higher priority, so they are in the opposite side, right?
Sir, I have a question. I'm telling that you have put wedge bond in the above BR and the dotted one in the lower BR. How are you assigning all these? Means it is not given in the diagram, it's given in the diagram
No,
dash
no,
bond.
no. Obviously, this is dash bond, but for the convenience of understanding, I am just drawing like this one. You can see this is a planar sp3 molecule, sp2 carbon, these two, right?
Yes. Hmm.
So this framework is also planar, but here as we can see, and for this one also, there the sp3 carbon is there. So just to understand the sigma bond where it is going, I am just drawing this one. You can also draw it in the plane bond, no issue. You can also draw it like this, but I am just trying to show or trying to tell that this is a double bond, and here the compound is optically inactive, so we will go for the E or Z
And Z.
nomenclature. Okay, and then
Okay.
from the double bond, it is showing that the two priority higher priority group are in the opposite direction, so this will be designated as the E. Okay.
Yes.
Okay. Okay. Any confusion? Okay.
No, sir.
Okay. Okay. So now we will come to the next question. Which of the following statement about the stereochemical descriptor of C1 and C2 center in the following alkane is correct? So now you first tell me which is the pro stereogenic center. Any idea?
Sir, if we change one atom in C2, then it will become a pro-stereogenic center.
One atom in C2, then it will become pro stereogenic center. At first, you tell me the definition of stereogenic center.
Sir, in any stereogenic center, if we exchange any two groups, then it becomes a new
New
stereoid.
molecule, right?
Yes, sir.
Yes. So, uh, absolutely right. Like if we take the so it is a stereogenic center. No, this is not
No.
stereogenic center. But if we add some group here, just
Then
for
it will become
example, I
C.
am showing, then it will become stereogenic center, right?
Yes.
Okay. So from the our question, let's start from the option C. Both C1 and C2 are the pro-stereogenic but not prochiral. Is it possible? Regarding C1 and C2, which one is the pro-stereogenic center? Regarding this group and this group,
C1.
sorry,
C1.
C1 is prostitution.
C1 is the pro-stereogenic, right? So as we can see that here two different groups are there, hydrogen and CO2 If a third group comes here, so the four substituents in this C1 will be different, right? And then if we
Yes.
change the two substituents, any two substituents on the C1 carbon, then it will become stereogenic, right?
Yes.
So tell me which option will be right?
A.
A, absolutely. So from our given examples or option A is right. C1 is the pro-stereogenic and C2 is pro-chiral center. Now tell me which one is the correct answer. The absolute configuration. Which one is the right? So at first, designate the priority of this nitrogen. Okay, we are trying to solve at first this carbon. Okay, sorry, this nitrogen atom. So tell me which one is the highest priority in the nitrogen
The
atom?
wedge bond. Yes, that one.
That one. Are you sure?
Means according to me, it is.
But if we see, okay, this one is the CH2, 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 right?
Yeah.
And this one is CH3. So it is
Hmm.
definitely above the lowest priority,
This
CH3.
is D.
This is D or 4. Okay.
Huh.
Now if we check around
The
this
above one is second one.
this one,
Yeah, that is second priority. Means 1, 2. That is 2.
okay. So if we look around this one, see at this is CH2 and this is C double bond
There was
C.
one C.
So which one is of the higher priority? This one or this one?
No, the above one because there is C double bond C.
C double bond C, absolutely. So this one is of the higher priority, right?
Yes.
Then the second, this one or this one?
C, C, C. Yes, C, C, C. There is double bond over there. C, there is P. Here the third one is containing double bond and over here is the third one containing P. Means attached to the carbon,
Yes,
the
yes,
third
yes,
carbon.
yes.
So P will be of high priority.
Sir, isn't double bond of higher priority this side?
Yes, double bond will be higher priority this side.
Why, sir? That is carbon and this is phosphorus.
But like the double bond is at the third position, but and the phosphorus is at the fourth position.
Yes, yes. Here
Oh
you
yeah.
have to check the number of carbon, right? It is in the of the third carbon, and it is
Yes,
taken
yes,
this
that is
side.
fourth. Yeah.
Okay, so this is 4, this is 3.
Hmm.
So if we put in the Fisher conformation, if we try to put, then this is 1, this is 3. Sorry.
So three will be
Mhm.
right one.
This one will be 4, right? This is 3, and this is.
So four will be below. Why is it going?
Sorry, 4 is this one, na, CH3.
That will be below. Means
Ah,
the down one,
yes,
vertical one.
yes, this will be 3. This will be, sorry, I again done mistake.
Please.
So what is this? Clockwise R,
Sir,
but the lowest priority group is in the horizontal plane. So it will be
S, sir.
S. And what about this one? It is R or S? Tell me what is the highest priority regarding the phosphorus?
But one with the benzene ring.
One will be the benzene ring, absolutely. Then two will be the
Two will be the lone pair.
no. Lone pair is always of the lowest priority.
Oh. Then two will be that this one.
This one, right? And
Yeah.
third one is the this one, and this one is
Lone
the
pair.
fourth. Okay.
Lone pair. CH3. Lone pair is less than CH3 even.
Yes, lone pair is always the lowest one. Okay.
Yes.
This one is the this continued bond. Okay. So one, two, three. So what configuration is this? This is anti-clockwise. So
Yes.
yes, and then lone pair lowest priority is in the horizontal plane. So it will be okay. So now is which of the following option is right? You know the concept of homotopic or enantiotopic or diastereotopic. Okay, so here the question is that two methyl groups in this following molecule are what? So these are the two methyl groups, right? Okay, so we have to change these methyl groups with the another molecule like CD3 or anything. We have to change this molecule. Then we'll check what is going to happen. Okay, so if we convert this in the Fisher position, let's first convert it to the Fisher conformation. Okay, let's first then change this one with the CD3. The rest will be same. Then we will change this one with the another CD3. The rest one will be unchanged. Now tell me, what is the relationship between these two molecules? This one and this one. What is the relation between these two molecules? Tell me, think around rotation or any kind
Sir,
of
homomers, sir.
how
Homomers.
how can you tell that?
Sir,
It is
rotate 180
image of the
degrees.
other.
Sorry?
Rotation on 180 degrees.
Yes, rotation around 180-degree on the plane of paper, like this one, right?
Yes, sir.
Then if we'll get the same molecule, this one. Or we
It is
can
a mirror image.
not mirror image,
Not mirror images,
not
same
mirror image.
molecules.
There, if we put a mirror here, then it is
Oh,
not mirror
oh
image.
no, it won't be reflected. No, 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 just not mirror.
Okay, so we can another say that if we think a C2 axis around the perpendicular of the plane of the paper and they twist the molecule, then we will get the same molecule, this one, right?
Yes,
So
sir.
Yes.
here, if we can conclude that if two groups are interchangeable by any axis of symmetry axis, then they are homomer. Here C2 is present through the center of the molecule, so they are homomer. And if any there is a plane of symmetry like sigma plane, then they are, sorry, homomer, yes, homotopic or homomer. The molecule is homomer and the groups are homotopic, and if plane of symmetry is present there, then they are enantiotopic. And if no symmetry element is present, then they are diastereotopic. Is that clear?
Yes, sir.
As here we can, is this clear, the C2 axis through the perpendicular to the plane of the paper, if we rotate the upside down, then we will get this molecule. So C2 is present, so they are homotopic to CH3 group. If they are interchangeable by the plane of the symmetry or like sigma plane, then they are enantiotopic. And if no such symmetry element is present there, then they are diastereotopic.
Sir, heterotopic?
Heterotopic is constitutionally different. We will discuss in the last example. Okay, there is a constitutional heterotopic problem is there. There the, if we change, in case of heterotopic, if we change the two molecule with the other groups like any kind of AX or CD3 as we done there, then they will be constitutional isomer. Okay,
Okay, okay, yes, sir.
yes. So is this clear? Homotopic, enantiotopic and diastereotopic.
Yes, sir.
Okay, then we will move to the next problem. So now tell me, which one is the right answer? You know the alpha plane. Which one is the alpha plane? So let first discuss regarding the re and z phase. You know what does it mean, re or z phase? Anybody?
Sir, what was the question?
My question is, what is the basic concept of this re and z phase? Means this re and z, or how can we determine this? This is my question.
Sir, after assigning the priority, if it is going in the clockwise direction, then it's R, re, and if it's anti-clockwise, it's C. I think so.
Okay, yes, absolutely. As we know that this is a pro-stereogenic center, now it is not stereogenic, but if we substitute some group here, so then it will be the stereogenic center, right?
Yes, sir.
So, according to the convention, if we put the carbonyl carbon as the one priority, then it is, suppose it is of the second priority and this is of the third priority. So it depends on from which phase the group is coming to the center, right? If we comes from the this one, then the absolute configuration will be different as per if we the group attacks from the this one, right?
Yes, sir.
Okay, so the two carbonyl group, this is a planar group, so it has the two phases. So if the group comes from the this side, so let's designate what is the priority of this one. 1, 2, 3. It is clockwise or anti-clockwise? If we check from the left side, this one,
Anti-clockwise.
anti-clockwise. So which phase is this?
S.
Not
C
S,
phase.
C phase, right?
Yes.
And if we check from the this one, which phase is this?
D phase.
Re phase. Exactly. So it depends from which phase we are looking at the molecule. Depending upon that, we will designate. We are designating this phase, this site as the Z phase, and this site as the Re phase, right? So the
Yes.
main concept is whenever some group is coming from this direction, it will be in the S configuration, and if it comes from this side, it will be of the R configuration. Okay, is it clear?
Yes, clear, sir.
Yes.
Okay. So now tell me, which is the alpha phase? The below one or the above one?
Upper one.
No, the upper one is the beta phase. Okay, the lower one is we call the alpha phase. Okay. So at first, let's check about the C1. So this is a carbonyl carbon pro-stereogenic center. So tell me, what is the priority order of this carbon? If we look around this carbon, what is the priority order? Which is your first priority?
Double bond O.
Are you sure?
Yes, sir. Double bond first priority. No,
But here, if we
no,
break this according to the
no, no, no,
Phantom
no.
atom, then here only C is attached, right? But here with
Yes.
oxygen, a carbon, that bromine is attached here. Okay.
Then the right hand side will be 1.
Yes, this one will be the 1, this one
This
will be
one will
the
be 2.
2, and this one will be the 3.
3.
And what is the order?
Reface.
Reface from, but we are looking from above or down?
Down.
No, we are looking it from the above. Just
Yes,
we are
yes.
seeing from it
Alpha
above.
phase is down.
Yes, alpha phase we have to determine, but now we are seeing from the above. And if it is Re from the above phase, then it is Z from the below phase. Just see, we are seeing from the above this structure. Okay, we are not seeing from the below this structure. This structure is like this one, no? This one. So if we are seeing this one, we are seeing from the above one. We are considering this carbon. We are we are assigning this priority looking from the above the group. Like okay, so from above it is come Re. So definitely from below it will come as the C phase.
Yes.
And now tell me about the priority of this one. Which is the highest priority?
So right side carbon, bromine attached. No, no, no. Oh, oxygen. Oxygen first priority.
Obviously oxygen. Here oxygen is
Oxygen.
directly attached.
Bromine
And now
substituted to carbon second
obvious,
priority.
yes. Here direct oxygen is there, but here carbon is there. Then some bromine is attached to the carbon. So
Yes, the
definitely the
second
oxygen will
priority.
get the high priority. And now this one is
Second.
Second. This one is
Third.
Third.
then from above it is
V.
re, and
From
then
above
from
it is V.
below,
C.
Yeah, C.
then what is the answer? Both
Both
are
C.
both C.
C.
Okay. Is it clear?
Here, sir.
Yes.
Okay. Okay. Now tell me pro R hydrogen in this molecule R. No, do you know the concept of pro R or pro S? So which we will call pro R. As it is not a stereogenic center, as we can see that they are both are hydrogen, but we are designating this one and this one as the different descriptor, right? Hydrogen A and hydrogen B. So we have to designate by substituting which hydrogen we will get the R configuration. Then we will call it as the pro R, right? Is it okay? The same one like this Re and the Z, we are designating, as we can see that only two same group hydrogen are attached to the this molecule. So is this a stereogenic center?
No, sir.
No. But if we change one of the hydrogen with some higher priority like deuterium, then it will become
Stereogenic center.
stereogenic center, and then we can put some absolute description R or S to this group, right?
Yes, sir.
Okay. So let's convert it to the Fisher formula first. We are converting hydrogen B with the D. Okay. Then hydrogen A will be as it is. We will check the what priority we are getting. Okay. So let's think about this center. Let's check out the priority first. Which one is of the higher priority? Priority 1. Tell
Sir,
me.
Bromine.
bromine.
Bromine,
Bromine.
obviously bromine is there. And then this
So, carbon.
carbon. And then deuterium or hydrogen?
Deuterium.
Deuterium.
Deuterium. Okay. So if we assign this 1, 2, and 3, then what is the absolute configuration?
R.
R. It is anti-clockwise, but lowest priority group in the horizontal plane. Then it is R.
Yes.
Then coming to the next one, we are converting here hydrogen D, this one with deuterium. Okay. So here, which one is our higher priority?
OH. OH.
Then this carbon.
This one.
Then this one.
Then D. Then HC.
And what is the configuration here?
R.
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 As the lowest priority is in the vertical group, so it will be as it is, right?
Yes.
So in the first group, which one is the pro R group?
HB.
HB.
HB. As we change the HB and we got the R configuration, so the HB will be the pro R, right? And in case of this center, which is of the pro R?
HD. HD.
HD. As we change the HD with the deuterium and we got the pro R. Okay, is this
But,
clear?
sir, if instead of deuterium we take some other higher group, then won't the configuration change?
Higher
Yes, you can.
higher group we definitely can check, but it should not hamper the priority of the other group. Okay, if we change the if we consider the very higher group means higher than bromine, then it can change the configuration or the absolute configuration of the center. Generally, we change with the higher isomer, means the isomer of the same atom. So it can just higher from the hydrogen, but it is not hampering the priority of the other group.
Okay, okay, sir.
Okay. Like the same way in case of CH3, we chosen the CD3, right? As CD3 is higher than the CH3.
Yes, sir. Yes, sir.
Okay. So is this clear? How can we determine Re phase, Z phase, and pro R, pro S problem?
Yeah.
Yes, sir. It's
Clear,
clear.
sir.
So now coming to the last one. Now tell me what is the answer? Is this homotopic? Is there any? Okay, let's first draw this in the Fisher formula, right? So now tell me, any kind of we have to consider this methyl group and this methyl group, right? So now tell me, are they convertible through any kind of symmetry axis? Are they interconvertible? This group and this group. Can we draw any C2 between this through this carbon? Means these two
No,
are
no, no, we can't.
okay. Is there any kind of sigma plane?
No, sir, there is no sigma plane.
There is no sigma plane. And if we change this ones with CD3 and in another set this with the CD3, then we get the two molecule. What are they? They are
So bonding is
constitutional
different.
isomer.
Bonding is different.
Yes, bonding connectivity is different. So
Connectivity
in
is
case
different.
they are
Astereomers.
not diastereomers, constitutionally heterotopic in this case.
Sorry. Yes.
Okay. So if there would be any kind of C2, means here it is a stereogenic center is there. So they are no, we cannot draw any kind of C2 axis or any kind of sigma plane through in between these two groups, right? So if we change with the another groups with these two methyl group, then they are constitutionally heterotopic. Their bonding connectivity will be different in both the cases. So they will call it a constitutional heterotopic molecule. Okay.
Yes, sir.
Okay. So any confusion from today's class? Anything? Any doubt or anything from today's class or last class?
No, sir. It's clear, sir.
Okay, it's clear now. Then thank you for joining. We will end up for today and we will again meet on the next Friday at the same time. Okay.
So
Yes, sir.
thank you,
Thank you,
sir.
sir.
Okay.
Thank you
Thank
very
you.
much.
Thank you.